Okay, we're working exercises from the plotting workshop and we're dealing with a linear inequality. We already did step 1, finding the table of values, and we already did also step 2, drawing the inequality with all of the stuff that I had to add. And what we're going to do now is to solve step number 3, finding the intercepts in this graph. Okay, because we're dealing with a linear inequality, there is not like a simple intercept. You have a lot of places where you have intercepts. Like if you see in here intercepts in x, there are plenty of them because the drawing touches the x-axis in a lot of numbers, from negative 0 point something until positive infinity. And you can see also in the y-axis that it starts from negative 2 and it goes until positive infinity. So they're like infinite intercepts in here. So we're gonna have to solve this thing in a different way than usual. We're gonna solve an inequality. So it's highly recommended for you to remember how to solve inequalities. You can see another video about that. And well, moving on, we're gonna find the x-intercept. That's what we're gonna do first. Okay, to find the intercepts, first we begin with the x-intercept. I'm gonna copy the formula of the exercise, and remember that to find the x-intercept, the other letter is gonna be 0. So in this case, the other letter is y. So instead of y, I'm gonna put 0. And then my goal is to figure out which number is x. So you can pass negative 3x to the left side. It's going to change its sign to positive 3. So you're going to have positive 3x greater than negative 2. The 3 is multiplying the x, so you can pass the 3 to divide. Because it's positive, then the sign is not going to flip. You only flip the sign when it's a negative number, a number that you pass to divide, but in this case it's a positive one. So you pass 3 to divide. It will be negative 2 divided by 3. Dividing by 3 is going to give you a recurring decimal, or an ugly decimal as we could say it. So we're going to leave it like that. Okay, you're not going to get a short decimal answer for this. So we leave the simplified fraction the way it is. And we're going to answer that the x-intercept is basically all of the x's greater than negative 2 or 3. If you checked how to solve linear inequalities, you know that we can write that thing in interval notation. And in interval notation, that will be basically something like this. Okay, we have the starting position will be negative 2 over 3, and because it's greater than but there is no equal mark, that thing's going to be open, and from there you're going to move on to the numbers that are greater, so that means you're going to put positive infinity. It's from minus 2/3 to positive infinity. You can make the drawing the graphic notation, and then you go to the interval notation if you need the graphic in that case to help you, or you can immediately jump and find the answer in interval notation. Once you put the answer like that, we need to remind the readers that this x-intercept it only applies when the y equals 0. So I'm going to put in here, after I put the answer, I'm going to put 4y equals 0, because I'm not writing them as points when I should write them as points, but it's impossible when you have infinite of them. So I specified that y equals 0, and the x's will be from negative 2/3 to positive infinity. I'm going to do the same thing with the y-intercept. So I'm going to copy the equation, which is y greater than negative 3x minus 2. And in this case, the other letter is x, because I'm talking about the y-intercept. Then the x is going to be 0, and you're supposed to find y. So I'm going to leave y, and instead of x, I'm going to put 0. So minus 3 times 0 will be 0 minus 2. And 0 minus 2, that will be negative 2. So we have y greater than negative 2. So the answers will be all of the letter y's that are greater than negative 2. So from minus 2 to positive infinity. So I'm going to put the y-intercept is, from negative 2 to positive infinity, and it's open because there is no equal mark. So it will be from minus 2 open to positive infinity, and we never closed infinities, so that one will be open too. And I need to explain that those are the y's, and for the points, all of the x's for those points, all of the x's are 0. And that's it. That's how you find the intercepts for the linear inequality. We write them in a different way because there are infinite of them. So we cannot just put we cannot put r because infinite doesn't mean all of the numbers. Like these numbers are not intercepts, only the ones that are colored. So that's why we need to specify from where to where, and the other letter is always 0.